March 2011. The Applied Physics Laboratory Ice Station, APLIS, perched on a sheet of ice 7 feet thick, adrift in the Beaufort Sea, 140 miles north of Prudhoe Bay, Alaska. The Arctic, changing and growing in scientific and strategic importance. Navy submarines come to APLIS for exercises in under-ice operations.
The Arctic is important not only to the Navy, but to the country at large. It's going to become a major sea lane. It already is a focus of what the Navy does in terms of cold weather exercise, in terms of submarines underneath the ice, which we're doing here, in terms of a lot of scientific experiments.
APL-UW scientists conduct tests and experiments, probing the waters beneath the ice with cameras.
You'll see the underside of the ice all the way around us. All the way around camp is pretty flat. If you know how to read the ice, you can actually tell quite a bit about what's happening here. There's probably less multi-year ice up here now.
At APLIS in 2009, cameras weren't enough, so APL sent divers under the ice to assist in Navy testing.
Let's go down to your hooch, since we're going to peek in there, right?
APL-UW builds and maintains the ice station and provides logistic support for several dozen personnel. Shelter?
It is plywood, yeah. It's insulated plywood panels. We have 2 sheets of plywood with a 2x2 strength member in between, and then it has, for the insulation, we have EPS foam.
Power.
This year we're running on one 9-kilowatt diesel generator, and it's turning out to be a very reliable machine.
Food and water. No freezer required for this kitchen. The Arctic is the sub-zero freezer just outside the door. 200 yards from the camp, the ice mine. Here, chunks of ice are chipped off and hauled back to camp to be melted down into the camp's only water supply.
The salt water in it melts and trickles down and dissolves the ice, and it's a process that basically transforms it from frozen salt water to frozen fresh water. So we go out and we find pieces of this older ice that is in fact fresh, not salt, because obviously we couldn't be drinking salt water. So that's a process that goes on all day long. They've got to do at least 3 trips a day to the ice mine to keep the kitchen going, because all the water in the whole camp comes through this system right here.
This is it.
A rear admiral pitches in for this work detail at the ice mine.
He doesn't have dwarven miners in his ancestry, I can tell.
To sit out there with a pickaxe and using a little back work to move that ice was hard. It was harder than I thought it was going to be.
Maverick.
Here's it.
Restarted. Delta. Sierra.
The command hut.
You. Reset. Delta. Sierra.
Here in the camp's nerve center, an underwater tracking system devised and operated by APL-UW keeps tabs on submarines maneuvering under the ice.
He's about to mark under us.
APL has been an outstanding partner throughout the execution of this ICEX. I am constantly amazed and with the professionalism of APL and really what they've done.
Submerged just a few miles from the ice station, a submarine commander slowly brings his boat up through the ice, right on target.
Right in the middle.
Good shot. Guys are directly behind us.
Awesome. Good job, guys.
Once on the surface, the sub faces yet another Arctic challenge, clearing the hatch of almost 3 feet of ice. APL personnel move in and quickly clear the way for the sub's crew to emerge.
There you go. Smile for Navy time.
The Arctic is only going to grow in importance, and it's incredibly crucial for us to understand how the Arctic operates how we can exist in the Arctic, and that's one of the great things that ICEX and this Ice Camp does.
Science at work for you. This is APL, the Applied Physics Laboratory at the University of Washington in Seattle.